Hi everyone, this is Mrs. Musoff. Today we're going to be talking about the properties of logarithms. Alright, so you can see in this purple box, I've got all the properties. These first four are kind of our basic properties that we already know, but just to have it written out. Alright, for example, if you have a logarithm, no matter the base, if your argument is 1, you know it's going to equal 0. Just like if you have a logarithm where the base is a and the argument's a, those are inverses, so they undo each other. That's always going to give you 1. Alright, and same kind of thing for these bottom two. If your bases ever match, the log base and the exponential base, they should undo each other and just leave you with the exponent or the argument, depending on the case. Alright, the main properties, and don't get me wrong, we use those a ton, but what we use in order to get to those properties are these three right here. Our product to sum, quotient to difference, power to factor. Alright, so what these properties tell us is if you have a log of a product, you can rewrite it as the sum of two logs. Alright, just like if you have the log of a quotient, you can rewrite it as the difference of two logs. And the last one says that if you ever had an exponent inside of your log, you can always take that exponent, bring it to the front, and it can become kind of a coefficient or a factor that you're multiplying the log by. Alright, so let's see how we can use these properties. And notice how these say evaluate without a calculator. So that's the whole reason we need our properties, is to help us simplify logs when we don't have our calculator. Alright, letter A and letter B are hopefully a little more straightforward. It's just re-emphasizing the idea that if you ever have a base of your log that matches a base of an exponential, they can undo each other. Alright, technically we can take this 71, bring it to the front, so it becomes 71 times log base 3 of 3. But then log base 3 of 3, we should know that that really just equals 1. Anytime our base and our argument are the same, that's going to equal 1. So this is really just 71 times 1, which is 71. Alright, similar kind of thing can happen in letter B. Again, remember a natural log is really a log base e. So this really says e to the log base e of 8. And since our base for the exponential matches the base for our log, we know that those undo each other, and so you would just be left with the argument. Alright, so kind of straightforward ways that we can use our properties. Letter C is a little different, just because now we have two separate logs, and it can be difficult to evaluate logs when your base is bigger than the argument. Alright, because then you're saying, like, what exponent would turn 8 into 2? Well, I have to really think in terms of radicals. That can get kind of complicated. So, instead, what our properties tell us we can do is if I have two logs, the sum of two logs, I can rewrite it as a log of a product. Alright, so, I'm sorry, not base 2, base 8, my fault. So, as long as they have the same base, so those both need to be the same number, as long as you have the same base, you can rewrite the sum of two logs by combining those arguments together into a product. Alright, and what that'll turn this into is log base 8 of 8, which again, using some of my other properties, I know that that equals 1. Okay, so just trying to either combine logs or separate logs, however we can to try and simplify them. Okay, same kind of thing in letter D. Alright, once again, I have these two separate logs, but if I notice they have the same base, I'm trying to think, how can I get these to go together? So instead of having two logs, how can I combine them into one log? Well, whenever you have a number in front, remember that's the same thing as an exponent. So I can rewrite these as log base 5 of 10 squared and log base 5 of 16 to the 1/2. And 10 squared, I know that that's 100. And 16 to the 1/2, remember 16 to the 1/2 is the same thing as the square root of 16. So I know that that would be 4. Okay, now still, by doing that, I still can't necessarily evaluate log base 5 of 100. I don't know what exponent would turn 5 into 100. It doesn't seem like it would work out. So instead I say, hey, I have two logs, the difference of them. I can combine, because they have the same base, I can combine these into a single log by turning it into a quotient. So instead of 104 being separate, I can write it as 100 divided by 4. That'll turn into just 25. And now log base 5 of 25, that is something I should know how to evaluate. That's just 2, because that's the exponent that would turn 5 into 25. Alright, same kind of thing in letter E. Again, a lot of people look at this and think that they can just cancel out the 3 with the log base 3's. But that only works when there's only one log. Like, let me scroll back up. This rule right here only works if it's a single log in the exponent. If there's more than one log, I can't really use that rule. So instead, when I look at this, I'm going to try and combine these into a single log. And I can do that because they have the same base. So that means I can just write them as a quotient since it was a difference. Right. Now that it's a single log, now I can simplify and it'll just turn into 5/4. Okay, so the whole goal of these properties is to make it easier to work with these logs, right? Sometimes you get complicated looking logs. If I can simplify it, right, make it easier to work with, I should be able to get my answer easier. All right, now in example 2, we're doing the same kind of thing. We're trying to use our properties. So whenever you see something like that, you should be thinking to use those properties. All right, write the expression as a sum or difference of logs. That's like trying to expand it out. Instead of having a single log, I want everything inside to get its own log. So for example, this 25 is going to have its own log, so I'm going to write it as log base 5 of 25. And then I'm dividing by these 2, but remember these 2 are separate. There's a 2 and an x squared. They're separate bases. So basically, each one of these pieces that I've highlighted is going to get its own log. All I need to do is really figure out the pluses and minuses behind it. Meaning, if it's divide, that should change into a difference, and if it's multiply, that should change into a sum. All right. So what I'm going to do here is I know 25 is on top, and then I'm dividing, so I'm going to do a minus. This is the part that gets kind of tricky because the 2 and the x squared are clearly being multiplied, so that would be plus. But since both of them are being divided by, what I'm going to do is I'm going to use parentheses, and then I'm going to use my logs for 2 and x squared. So log base 5 of 2 plus log base 5 of x squared. All right, and then since in order to get rid of parentheses, I just need to distribute this minus. So it'll turn into log base 5 of 25 minus log base 5 of 2 minus log base 5 of x squared. Okay, and it makes sense that in the end both of these would be minuses, because when we ask are we multiplying or dividing, we're really asking in relation to the first piece. So in relation to 25, both 2 and x squared are both being divided, so that's why they would both get minuses. Okay, if I have any exponents left over, I'm going to bring those to the front. So I'll have log base 5 of 25 minus log base 5 of 2 minus 2 times log base 5 of x. And then the whole reason to do all this simplifying is to hopefully you end up with an expression that can completely simplify, like log base 5 of 25. Right? I know that that equals 2, so I can completely simplify it. Alright, log base 5 of 2, I can't do that because that one doesn't work out as nicely, so I'll leave that one as is. And since this one has an x, I definitely can't simplify that one, so I'll leave that one as is as well. And that would be my final answer. Alright, same kind of thing in letter B, so I'm going to look and see how many different arguments are going to separate into different logs. So here I have an x squared, that's all going to go together, right? The squared is just going to come to the front. And then I have a cubed root of x minus 1. That all has to stay together because when we talk about how many arguments, it's like, what are we multiplying and dividing? So you can't split up the x and the 1 because that's not multiplying or dividing. Okay, and then this is multiplying, so that means when I split it up, I'm going to turn it into addition. All right. And then we talked about this yesterday a little bit. Anytime you have a third root, we want to try and remember that's the same thing as a 1/3 exponent. And it's really important that you're able to convert radicals to exponents because exponents are what really help us with logs. So I'm going to rewrite this. This will be natural log of x squared plus the natural log of x minus 1 to the 1/3. Now I can take these exponents, bring them to the front, and see if I can simplify anything. 2 times the natural log of x plus 1/3 times the natural log of x minus 1. All right, since both of these have variables in it, I can't simplify, so this would be my final answer. All right, so again, we're just using our properties to break things apart and see if there's any simplifying. And we can do the same kind of thing to put them back together. So like in example 3, it asks us to write the expression as a single log. So that's trying to put these logs back together to see if any simplifying can take place there. So for something like letter A, we're going to do the exact same thing we were just doing, but backwards. Right? Because if you take something apart and then you want to put it back together, you do the exact same steps, but in the exact opposite order. So that means I'm going to take these numbers first, put them back to exponents. So it'd be log of u to the third plus log of v to the fourth. Don't get confused if you don't see a base. Remember, if there's no base and it's just using the word log, that's a common log. So that's like a base 10. You don't have to write it in, but just know that it's technically there. And then addition, if I want to write it as a single log, that means I'm going to take the sum and turn it into a product. All right. So my final answer would just be log of u cubed v to the fourth. All right, same kind of thing in letter B. Now, a lot of people get confused when they see addition and subtraction inside of the log, but don't be confused by that. Remember, our properties really only work, let me scroll back up, if it's multiplication or division inside. The addition and subtraction has to be outside of the log. So if you ever see addition or subtraction inside of your log, just know you're going to let it go. You're not going to be able to do anything with it. You're just going to try and use your other properties to see if you can simplify other pieces. All right. For example, I can take this 2, move it to the exponent. So I'll have log base 2 of x squared plus 3x plus 2 minus log base 2 of x plus 1 squared. And then since it's subtraction, I know subtraction can turn it into a quotient. So when I try and write this, there we go. When I try to write this as a single log, the way I'm going to do that is to combine it into a quotient. So x squared plus 3x plus 2 divided by x plus 1 squared. And remember, order in dividing does matter, so make sure the top is the top and the bottom is the bottom. You don't have it flipped. Alright, and if I wanted to try and simplify it, I could factor what's inside. X plus 2, x plus 1. The bottom's already factored. And then I can simplify. One of these x plus 1s will cancel out. So I'm just left with log base 2 of x plus 2 over x plus 1. Alright, just one last thing. Alright, there is one more property. It's called the change of base property. Alright, the reason for the change of base property is because on your calculator there are only 2 log buttons. There's the log, which is the common log, that's a log base 10. And then there's the natural log, which is a log base e. But that's it. There's no button for a log base 7 or a log base 15, right? So in order to make it so we could type any log into our calculator, we had to come up with a property that would work. Alright, and so there's this property that says that if you have the log with any base and any argument, you can rewrite it into a different base as long as the argument is on top of the logarithm, the old base is in the bottom, and now it becomes a quotient. Alright, c can be any base greater than 0 or not equal to 1. And typically we'll see it used as 10 and e. So a lot of times you'll see this written as log of m divided by log of a, or natural log of m divided by natural log of a. Alright, so for example, with this one right here, evaluate with a calculator, a base 2 I would have no way to type into my calculator. So instead what I do is I rewrite it, and I usually will rewrite it with either a base 10 or a base e. So if I did a base 10, it would be the common log of 17 divided by the common log of 2. Or if I did a base e, it would be the natural log of 17 divided by the natural log of 2.